Okay, it is 4 o'clock, let's get going. So this one is about Microsoft's Hadoop offering. And what I'm talking about is the thing called HD Insight that runs on Azure. Hopefully I have internet. I should really check that beforehand. Shouldn't be around. Okay, and actually what I'm going to do is make myself an HD Insight cluster to sort of give me a chance to get going. These HD Insight clusters take about 10 to 15 minutes to make. And so we'll make it so that we can get going before I do. Just to make sure. Oh, good. Okay, I have internet. That's good. Because I'm going to submit all these jobs from my phone, and so if I didn't have internet, I just have to stand up here and go, if I submitted this job, it would do this, you know? So anyway, this is my Azure account. If you were at the talk yesterday, you know this one. And basically the big difference between Microsoft's implementation of Hadoop and everybody else's is that they don't use HDFS. They provide HDFS, but they don't use HDFS by default. They're using Windows Azure Storage by default, and I'll talk about why coming up. So at this point, notice that, oh, did I not actually put the, I thought I did that. Here we go. See, I'll give you this one as a spatial Hadoop. Okay. So at this point, I have these things here, and I have my storage account in Europe. And so that's the one I'm going to use because it's closer. And what I'm going to do first is I'm actually going to put out a SQL Server database. And the reason why I'm going to put out a SQL Server database or a SQL Azure database is because that database is actually going to contain the metadata for Uzi and Hive. Basically, the metadata is just what file names are, what tables are out there, what files they point to, and so forth. And the premise of this build, or the premise of this way of doing it, is you bring it up when you need it, you do something, and you bring it down when you don't. So what's nice about having the thing on a SQL Azure database is that if I just want to bring it up again, it knows what this database looks like for Hive. So I'll show you the database when I bring it up. So I'll go to the SQL databases right here, and I want a new one, and I want to import one from one of my backpacks. If you came yesterday, you know what a backpack is. And I believe I have one right here. There's backpacks, and that's not a good one. Let's try this one. Okay, I want the pups backpack because I'm actually going to, there it is. I'm going to do a, oh, we have to do this F11 thing again? We'll find it the hard way. So that's the file name, okay. And then what I'm going to do is I'm going to name the database pubs there. And I want this to be part of my Azure Cloud Essentials because that's running out in a few days. And choose a server, which is going to be the one in Western Europe. And I'll log into it. Hopefully I can remember my password for this morning, we'll find out. There. Let's see if it works. Oh, here we go again. So we'll do F11. Here. So go. So all this is going to do is restore my database. And actually, if I have this from before, it should have my Hadoop metadata already there. In fact, we could take a look just to cheat. Did it not like that? Oh, it's working on it. Okay. Ooh, error. Nice. What is it upset about? Could not import database pubs. That's helpful. If it doesn't import one more time, we'll just forget about it and do something else. So, all right. New. Import. And then backpack URL. So I go look for one. Fine. Because I believe this has my Uzi metadata from before, and I wanted to show you troubleshooting the problem. So we're going to open that, and then we want the name of the database to be pubs. And we want the subscription it's under to be this. And we'll choose a server. Maybe it's upset about the server. I'll choose it. Okay. That's fine. Oh, maybe it didn't like the fact that I logged in right because I've been changing passwords around. So I believe this is my password for this server. Let's see if that's not right. Go. It's thinking about it. There it goes. I like these little things. Oh, no, didn't like that at all. Okay. Well, one more time, we'll actually just make a new server. Maybe it's the password that I forgot. Okay, so one more time. And if it's not, then we'll just use it without it. So import that again. This is a bunch of different storage accounts that I have, and the other reason why I might be upset, there we go, right, is that here. It's not on the same subscription, although that shouldn't really care. And we'll put it out here. And, you know, we'll actually make a new server because maybe I forgot the password. Okay. And the server password is going to be this. that's why. I bet that's because I changed the password, so it wouldn't be my usual password. Let's try this one more time, and if not, we'll go here. All right, ready? Go. So I was actually going to show you my password, and I didn't want to show you the one I use all the time. Sorry. The password for this time is password. Is it? Okay, it's still going. And we'll get rid of this one. Okay, so it's importing the database. And just to make sure that happens, we can go back into SQL Server Management Studio. So F11 on this. And once it gets restored, we can see some of the Hbase metadata that's in there. Okay, there we are. I don't know how much people know about all the different parts of Hadoop. So Hive is like the data warehouse for Hadoop, and it actually has a SQL-like language. And Uzi is actually a workflow engine that you can use, sort of like SSIS if you know SQL Server. And so these keep their metadata wherever you want. Remember I said that we will forget it if that's the case? Well, we wouldn't forget it, we'd just use an empty new database. Okay, I don't think any of these databases are in here, goodness. So what's the name of that database? Okay, so now it's online, good. And the server I have is this one over here, EC something. So click it so that I can copy and paste it. There we go. Yeah, that's what happened is I changed my password. Okay, so we'll go here, and we'll actually go to that instance, and basically I just want to make sure I spell database.windows.net correctly. And I'll type in my name and my password. It's very strange too. I found this out the hard way after about 4 hours one day. Some of the Hadoop utilities, like Uzi, does not like like Scoop. Scoop is like bulk copy if you're doing SQL Server. Scoop does not like passwords that have an exclamation point in them. It took me like 50 invalid logins to figure that out. Okay, so there we go. And we can go to the new pubs database, and let's see if that metadata is still in there. So what's nice about this is that it thinks all of my metadata is in place. Of course it's not, so that'll be interesting. Let's see what tables we have up there. Okay, good. Now that's the regular pubs tables. Okay, so we haven't got it in there yet. Fine, we'll have it make it. So now what I want to do is it's a good thing too, because I don't have any of that Hadoop stuff here. So because I'm doing it in my Europe account. So this is called the Azure Storage Explorer, and it can look at storage accounts. And I have one that I made for Europe, so it'll be tolerably fast. So there's the European one. And basically what I put in here is two directories. Well, don't point at that resolution. There we go. Put in two directories. One is called Hadoop 21, and the other one is called Hadoop 3. Hadoop 3 is the newest one. Hadoop 21 is one release beyond that. And basically right now, this doesn't have any files in it at all. We're just empty container, we're going to use it. That's where we're going to put our Hadoop files. So now let's go back and make our Hadoop database. All right, and where is this? 11 again, there we go. There's the HD Insight database, there we go. And we'll produce a cluster. And basically you can either do quick create or custom create. I'm going to do custom because I want the latest release. Now you name your cluster, and then this will be Azure HDInsight.net. The subscription you want to use, so the same one. And you tell it how many data nodes you want. You pay by the data node by the minute. So because you pay by the data node by the minute, I'm going to move out and get 2. Right, 4 is the default. And then you can tell it the HD Insight is included. And this is probably strange, so strange I'll mention it again. Microsoft uses different version numbers than the rest of the Hadoop world. So in the rest of the Hadoop world, you hear things like 1.1, 1.3, and 2.0 or 2.2. And so in Microsoft land, 1.1 of Hadoop is actually 1.6. And 1.3 of Hadoop is actually 2.1. And Hadoop 2.2, which just came out, is 3.0. And I have no idea why they just didn't use the same version numbers as everybody else. But we're going to go for the 3.0 version because I like that one. And in order for me to have this, I have to have a storage account to put it in. So if I go to Western Europe, I already have a storage account. Everybody understand what Windows Azure storage account is? It's just like a file system. And basically, the storage that I'm actually using is called blob storage. You could have blob storage, NoSQL table storage, or queue storage for, say, queue messages. Okay, so I'm going to do that in Western Europe. Go on to the next one. I'm going to configure the cluster user. And by the way, the canonical name for the cluster user is admin. And unless you have a good reason for doing that, you should probably use admin. This also cost me a couple of hours here, because one of the Odbc jobs I was running wanted the admin's name, and it had admin hard-coded. It's like, that's nice. Took me a while to figure out what they wanted. And this is password with a $, and then, oh, right, it's saying it's not the same, no kidding. Right, there we go. And so at this point it says, where do you want your Hive and Odbc metastore? In other words, where do you want that metadata? Now, we already have some some tables in there, but we can use the same database. You do have to have the database in place if you want to put it in a database. And if you don't have a database in place, it'll use a specific kind of database called, Derby, the Derby database. Some people think of Derby as the access of the Unix world. Why doesn't it like this thing? Hold on. Don't tell that to the Derby people, they'll be upset at me. Okay, you happy now? No. There. Okay? Okay? Oh, come on. What is it upset with? Oh, must contain at least 10 letters, I'm sorry. Yes, all my passwords are 8 letters. So this is 1, 2, 3, and 1, 2, 3. Now it's happening. Okay. I forget about that. They need better passwords than the rest of the world. Don't ask me why. Okay. So the database user I'm going to use is the one that I put out there as the administrator. And this one I can actually use my 8-character password. They're actually 9-character password. Good. And it'll actually go and look and make sure that stuff is out there. That's what that pending was. So now it knows what version of Hadoop I want, where I want to put it out on the Azure file system, and also what database I'm going to use for the metastore. Just think of the metastore for Hive and Odbc as the sys tables and the sys procedures and that kind of stuff. We'll see it when we go out there. Okay, so it says, where do you want this? I don't want to create a new storage account because they name it something hideous. So we use an existing storage account. Why doesn't it like the fact that I want to use an existing storage account? Sometimes it gets upset. Come on. I'm not happy. Worst comes to worst, I'm going to create new storage then. From another subscription? Okay. And what storage account do I get from another subscription? Sometimes this actually takes a while to refresh, which is just a world pain. Okay, we'll create a new one. So there's a thing. Okay, so there's a new storage account. It won't have the nice Hadoop 3, but that's okay. And the account name that I'm going to create is new. Okay. And the default created container is new. And so you'll be able to see what it creates when we come out here. Now, you get one storage account, that's where you actually put your file system for Hadoop. When you normally get Hadoop on Linux, it's installed on a machine and it's installed on the local file system. When you create this, you're actually using the file system of the Azure storage. No, it still isn't like that. Anyway, good. So, what is it upset about now? Account name? Okay, so we'll make an account name. Oh, good. It's happy to give me whatever account name I want. That's nice. How about new account? Watch what happens. No, the account name is already in use. Okay. New BBAUCH. Good. Nobody uses my name. Okay. And so the default container in that, we'll call it Hadoop 3. So it's actually going to give me an opportunity to name my container in my storage, whatever I want. Now, in addition to the one storage account where they'll actually put the files, you can choose to put your data up there with the files, or you can have as many as 7 additional storage accounts. So right now I won't have any. We'll just use the one that's up there. Ready? Go. And after 15 minutes or so, we'll have a Hadoop cluster. And we can have it for as long as I want. Now, if this is too much hassle for you to do this way, there's actually PowerShell scripts. And people have written PowerShell scripts to provision a Hadoop cluster, run a couple of jobs, and then take the cluster down. Because once that cluster's up there, I can just go poof and delete it and it's gone. But when I delete the cluster, it doesn't delete my storage account. So all my data is up there. Everybody good with that? That's supposed to be its big claim to fame, right? Is that you only have to pay for it when you're using it. And if you actually put stuff out on the, it's going to make a virtual machine with Hadoop on it. And if you put stuff out to the virtual machine, it's going to be gone when the virtual machine is. If you put stuff out to Windows Azure Storage, then it's always going to be there. Okay, so it's submitting the thing for the VM, and we'll just sort of let this go for a while. I started it early, like I said, it takes 10 to 15 minutes. Actually, we'll see how long it takes in Europe. Does that at home. So this is who I am. I don't know how this got in here, but I don't work at Microsoft anymore, even as a vendor. Goodness. They'll be upset. There. Twitter handle, books, you've seen this before. Okay. So we're going to talk about getting started. In fact, we just did get started. And if those names didn't mean much to you, we're going to talk about what those names mean. Hive and Uzi and Scoop. And basically, Hadoop is based on somebody's name of their toy elephant, their kid's toy elephant. So you see they use way too many animal names at this point. That's okay, right? Who knows? You've seen the SQL Server code names, right? So get started, cluster creation, access methods, Hadoop on Windows Azure Blob Storage, and tools for this. And then we'll submit some jobs. So the Hadoop core, the Hadoop itself, actually consists of two main parts. In fact, they are the two parts of Hadoop. They have always been there. The rest of the stuff, like Hive and Uzi and Pig and other things, I forgot about Pig. Hive and Uzi and Pig, those are sort of packages on top of Hadoop. So two main parts of Hadoop is a fault-tolerant, grid-based file system called HDFS. And basically, when you write to the file system HDFS, it writes 3 copies of everything, and it scatters it all over the machines that you have. And by the way, starting in version 2, Yahoo actually was able to go from 40,000 machine clusters to 400,000 machine clusters. So this is like big machines. I always had this idea in my head. You've seen the movie The Matrix, right, where they have all these different machines and little children or fetuses or something hanging off of them and they're making electricity with them? That's what I always have in my head for this thing, right? There's way too many of these machines. They're going to suck all the electricity out of the atmosphere. But be that as it may, right? There's a There's a fault-tolerant file system. And HDFS can be run on a grid of computers, at least 3 for fault tolerance, because they will actually make 3 copies of each piece of data and just put them out in the ether out there. You can run it on a single computer, and so all the vendors have a single computer try thing, VM, that you can go up and download on their from their website. And of course, that's not going to run with fault tolerance. However, HDFS 1 actually isn't fault tolerant. We'll talk about that maybe later on. So that's the first part, is HDFS. And by the way, Windows Hadoop by default, Windows Azure Hadoop by default, doesn't use HDFS at all. If you want to use HDFS, it's out there, you can use it, but HDFS, even the command line utilities, are set to go to that Windows Azure storage. And why is that? Well, because when you bring it down, the Windows Azure storage sticks and the HDFS would go away. Sure. Okay. The second part of it is a framework for running jobs called Mapreduce Jobs. And Mapreduce Jobs are basically long-running batch jobs. And their claim to fame, at least one of them, I was trying to figure out how to do Mapreduce in like 20 words or less. Mapreduce was the paradigm that Google invented, and Google uses to re-index all of the web pages in the world every day. Before they invented this MapReduce system, it used to take them 2 or 3 days or a week to re-index their set of pages, their search engine of everybody's pages. And when they invented this MapReduce, it's only going to take a day. Now, that's all it can do. Until version 2 of Hadoop, it runs MapReduce jobs and only MapReduce jobs. If you submit a Hive query that looks like SQL, it makes it into MapReduce jobs. If you submit an Uzi workflow, it's actually a set of MapReduce jobs. If you do data cleansing with Pig, then it's actually a set of MapReduce jobs as well. That's all it can do. So version 2, one of the things that they wanted to do with Hadoop version 2 was actually run jobs other than MapReduce. Now this system is written in Java, so Java is actually the native API for it, and it almost always runs on Linux. I believe IBM has one that runs on their hardware, but they have Linux as well, or they have a Linux offering. There's one that runs on Amazon's Elastic Cloud, but mostly it's boxes on Linux in these big data centers where there's a million different machines. And the reason why the HDFS is as tolerant as it is because they're going to use commodity hardware, and they think it's possible, in fact, they're pretty sure it's possible, that the hardware is going to break while they're running the Mapreduce job. And if it breaks, they just start that part of the job over again. Now, besides the fact that it was made popular by Google, what exactly does Mapreduce do? So, Mapreduce is a framework for running jobs. They run in batch. I always thought it was funny. I'm old, right? I started in this IT world in 1977, really. I've had people go, I wasn't born in 1977. And in 1977, right, it turned out that the cool people, right, the people that had the cool jobs would actually do online transaction processing. That was a big deal. And either the new people or the old and lousy people would do batch jobs. And they'd watch these batch jobs run all night. So I think it's kind of hilarious to think of these recent college graduates going to Google because it's a cool job and spending their entire night watching Mapreduce jobs run. But maybe I get too easily amused. Okay, so jobs run in batch, they're not interactive at all. When we go and submit a Hive query at one point, you think it would come right back. We're going to do a query to look at the tables in Hive. And it's going to go run a map job, and then run a reduce job, and then come back with the answer, and then reduce it down to one answer, and then they're finally going to get it. It's hideously slow. But again, it works well with a lot of computers. So basically, there's a Mapreduce functional programming model. Anybody do the programming language F# in the Microsoft world? Okay, F# is a functional programming language in Microsoft. And they actually have methods on classes called Mapreduce. What the idea of Mapreduce is that the map step is used for filtering and sorting. I could run around and point at this stuff, but I'm just going to sit here. The map part is used for filtering and sorting, and the reduce step is used for summarization. So imagine if you wanted to, I'm not going to count words, right? Imagine if you wanted to get a summary of, goodness, the sales we have in a particular decade on a year-by-year basis. One of the things you might do is you might fire off a map job for each year. And then when the map job comes back with the data for each year, then what you would do is take that data and reduce it down to a single answer. In fact, if you're a SQL Server aficionado, there is such a thing as partial aggregation and full aggregation, and that's really the closest SQL Server has to how Mapreduce works. Right? If you look at a data warehouse query plan, I was going to bring one out, but if you look at a data warehouse query plan, you can see that it'll do some of the aggregation first, and then it'll take all the aggregates and do aggregation over those, and that's basically Mapreduce. Hadoop provides two common APIs, and the cool one is the native API that's built in Java. And so to run the cool one, you actually have to build Java libraries, and the code is written in Java, and your classes must implement certain interfaces. However, there is a streaming API for the rest of the world that's built around standard in and standard out. Right? Your data comes in through standard in, you break it up, and you put out the answer in standard out. And then they do what's called the shuffle of the intermediate answers. And the reduce step gets data from standard in, and then puts it out in standard out. I'm going to show you the version of this that runs in .NET. In fact, this is a good place to do that. So, in here someplace, there's actually source code in Java and in .NET for the word count. Oh, well, he asked me before if I was going to run a word count, because that's what everybody does. And we'll start with it anyway. So over here, there should be, let's see, word count right here. And this is the word count in .NET that uses the standard in and standard out. And basically what this is going to do is take documents and break them into n chunks, however many n is, and then it'll count the words in those documents one at a time. So it'll basically come up with a word that starts with A is done once and again, and another word that starts with B is done once and again, and they pass those back to the end of the map job. And then reduce, they take the words and summarize them. So by the end of the day, you get so many letter A's and so many letter B's and so many letter C's. But this is fairly just simple to do, especially with this API. Here we go. So in our main program, and notice this isn't really spectacular. right? It's a console app that's running on the console, really, running on the Windows console. And so in our main program, we're basically going to get stream readers in from these files. And once we read the stream reader line at a time, while we still have a line left, we'll break up the line into words and we'll count the words. Now in the first part of it, they just put out word A, one, word A, another one, word A, a third one. So you're going to get all these things in counts. They don't do any summarization here. And then when they're done with these, they just call console.writeLine. So it's pretty easy to do. They're just using the standard. And then with the reduce part of it, they'll do a similar thing. I can also show you the Java version of this. The Java version of this is a little cooler, right? And this is actually the Mapreduce right here for .NET. So there's the mapper right here. We saw the mapper, but we didn't see the reducer. And there's the reducer someplace. He said, okay. So it's a pretty simple concept, right? You just run two-step jobs until you're tired of it. That's all it does. So in this case, we'll get a set of word one, word one, word one. And in the reduce job, we'll just summarize the words, count plus one. And then at the very end, we'll put out word A has 57 of them and word B has 45 of them and so forth. And we'll see the output when we actually run this thing. Okay. For the Java one, it looks a little cooler. It's the Java native API. So where's that? Goodness. So there should be, we'll just look for it. There. Okay, there it is, word count in Java. And this is the first thing, like you said, it's the first thing you teach everybody when they start to do Mapreduce. A lot of imports for different Java classes. And you have a class called map that extends the mapper. And basically what you get is a long writable set of data, name value pairs, right? That's what comes in out of your data is name value pairs. And so in this case, they're just using the Java tokenizer to tokenize each line. Well, I thought you said it was name value pairs. Yeah, well, the name is the number of the line, and the value is the line itself. Okay. Now, what else do we do once we've summarized those? Well, we have reduce that extends the reducer, and again, we're adding them together here. Supposedly, the Java API is supposed to be faster. I'm not so sure. Everybody okay with that? So that's Mapreduce enough to try not to harp over it. And the premise with the Mapreduce and the real Hadoop, the Hadoop that runs on Linux, is the fact that what you're supposed to do, HDFS is a file system that keeps information about where its data is. And so what happens when you start to run this Mapreduce job is the job itself, the Mapreduce framework, goes in and queries HDFS, and HDFS says, oh, I got data here, and data here, and data here, and data here. So what it does is it pushes out the jar files, the Java code, to each node that actually has data. And this is supposed to make it run a lot faster. The fact that the code is actually co-located with the data. Now, I talked to somebody, I believe he may have done a Hadoop talk at this conference. He's been working with people at Microsoft that are doing something called Dryad. Did you go to a thing where the guy mentioned Dryad? And basically he said this co-location of data and processing is sort of a myth, right? It's not as good as it's cracked up to be. Because after a while, they don't really know where the end of the data is, where the rest of the data is, and so they just start assigning nodes because they happen to have some data on them at all. So it's not like it's anything, exactly accurate that part of the data will be over here and part of the data will be over here. And by the way, in the reduce step, they move the data around, right? They bring the data back to the middle, and then they actually shuffle it around and they move it out again. None of the reducers at that point have the data locally. They have to push it to them in the reduce step. Everybody okay with that? The reason why I cared was because our stuff is going on Azure storage. And so I thought to myself, well, there, you've lost a big part of Hadoop, right? HDFS data is supposed to be location aware, and you're running everything on Windows Azure storage. That's not a good thing. Turns out that the way that they gen these up, these processors, they actually run on Windows Azure storage in a private LAN that's tremendously fast. So all the data pretty much is close to all of the storage in that case. And by the way, Windows Azure storage actually replicates itself 3 times. So it's as good as HDFS as far as replication goes as well. Have I convinced you yet? Okay. I said that to somebody, I said, well, but you don't have location of data. And they said, we don't need it, we have a tremendous high-speed network. Okay. So the Hadoop ecosystem is basically the core platform, plus a bunch of products that people wrote that run on it. Actually, most of them aren't products as such, they're Apache projects, Apache open source projects. So one of the nice things about Hadoop is you can get the source and you can compile it yourself. Or you can get built versions of it and install it that way. So the core Hadoop platform is HDFS and Mapreduce. There's a non-relational database based on Google's big table database called Hbase. And have you heard of Google's big table database? Basically, the big table is based on the fact that you're going to get a lot of data, and some of it you're not expecting, right? Basically, Google's going to read all the Google tags on your page, and at that point, it's going to give you all the data that anybody wanted to collect at all. Now, Google doesn't have to actually say, I want A and B and C to be columns in my table. What they do in Hbase and in Google's database is they actually have what's called column groups. And so what you do is you make up column groups, and those column groups are hard-coded. And if you see something that you haven't seen before, it just goes in a column group. Anybody in SQL Server people know what this sounds like? Sparse columns, right? Column group for all sparse columns, except they have many column groups, and you can define as many as you want to. So if I wanted to see, for example, medical data, I might say, okay, I know that this and this and this is going to come in, but if I'm not expecting the 4th piece of medical data, I can just put it in that column group, and you can add columns on the fly that way. Everybody okay with that? I'll give you my big data talk later on if you want. This is what is big data. Okay. There's also metadata services. So these guys, Hive and Oozy, actually have to know where their metadata is, especially if you think of Hive as a database. They have to know where their tables are. And so it used to be that this metadata was a separate product that was called HCatalog. And now HCatalog has been sifted into Hive. So there's really not a separate HCatalog anymore. And by the way, we should be able to see this, but finish the slide. Okay. There's also, so when they wanted to ingest data, they ingested it in 2 different ways. Remember, first of all, Google invented this stuff, right? They didn't patent it. They put out a white paper, or they want you to use theirs, but they put out a white paper, and basically Yahoo took it up and programmed it as an open source implementation. When they got to the way to interact with the data, there was a difference of opinion. And so Yahoo people actually wrote this scripting platform called Apache Pig. And the reason why it's called Pig is not just because it's a cute animal name, but the premise is supposed to be that pigs ingest anything, right? So you can basically shove any data you want into the pig, and it will ingest it. Okay, that's Apache Pig, and that's the one that Yahoo uses. However, Facebook did not choose to use Pig. They wanted something that look more like a relational database. And so they made up this thing called Hive. And Hive makes it look like a database, or technically a data warehouse. So Facebook invented Hive, and Yahoo invented Pig. And you can choose to use Hive or Pig yourself, or you can use a combination of the 2. Now, it's nice to be able to run these queries, but what you're really doing with this big data is you're ingesting it and you're running predictive analytics on it. Right? You've heard of the big predictive analytics story in the US. So there was a girl in the US, 17 years old, who apparently started getting these advertisements. And she got advertisements as though she was pregnant. However, she didn't know that, and her parents didn't know that. And it turns out that the store that she went to actually had figured this out by predictive analytics. And so when the parents found out, they were not that happy. And when she found out she was not that happy either, that this store knew about her before she did. Right? That's predictive analytics or targeted advertising. Right? Basically, you figure out, you figure out patterns in things, and then use the pattern to predict what's going to happen in the future. Now, the big pattern predictor that they have that's similar to, data mining, although the data mining guy down the end there doesn't like it, is called Mahout. And Mahout is actually, I think in India, it's the person who rides the elephant, the person who, okay. So if Hadoop is the elephant, Mahout is the person who rides the elephant. And basically there's every machine learning algorithm under the sun, and basically you can use this to do predictive analytics, which is the point at the very end. Now people make fun of big data, right? And I made fun of it up until I thought there's this company that's a multi-billion-dollar company called Google, and why would I make fun of a multi-billion-dollar company? Right, so anyway, they all use this stuff. There's also Cluster Coordinator, and we don't even have this in the SQL Server, the Windows Azure version of it called Zookeeper. And basically what Zookeeper is used for is configuration information and information about how to fail over things if they fail over. There's also a management and monitoring piece, which is called Apache environment. Because basically if you're going to run all these batch jobs and come in first thing in the morning, you want to know what happened. And you want to make sure that your job worked over the evening. There's also some data integration services stuff. So HCatalog has a bunch of APIs. There's REST-based API for HDFS called Web HDFS. Microsoft's made an implementation of that. And Apache Scoop is a way to be able to take data out of Hive and put it into a database, or data from a database and put it out to Hive. And when we get to it, I should stop naming all these names, we can actually see how this works. Because there's so much and logging is so important, they also have a set of log management services called Apache Flume. Flume is like the log flume, I guess. Everybody okay with this? Again, I'm not trying to make fun, right? At all. Okay. So basically it's an open source project, you can compile it yourself, but they have a lot of big vendors that are using these, and it seems like every big vendor has aligned itself with another great Hadoop vendor. So when Microsoft picked out a vendor, they picked up Hortonworks. Hortonworks is a bunch of people that used to work at Yahoo, quit Yahoo and formed their own company. And Hortonworks is pretty good for actually keeping the source code the way it is, right? Not making specialized changes to the source code. Whereas there's another vendor called Cloudera, and Cloudera is aligned with Oracle. And Cloudera will get further along in the Hadoop world than the Hortonworks folks. But they do it, and you have to use it by actually installing a bunch of Cloudera-specific fixes on top of the source code. So Cloudera stuff is open source, it's not like it's not. And they actually extend the open source quite a bit. But the open source usually only works if you have all Cloudera's fixes to the source code. There's also a company, the original company, called MapR. And MapR, I had somebody tell me yesterday, MapR is a Hadoop. And I said, why is that? And they said, because MapR is written in C. Oh, that's enough to make it not Hadoop. Programming language, big, right? So MapR is actually the one that's aligned with, goodness, the original Greenplum. Greenplum actually runs under MapR. And MapR also doesn't really care for HDFS. So what they did was write extensions so that you could run Hadoop on NFS, the Unix Network File System. Okay. Also, IBM has their own implementation, and Amazon Elastic MapReduce basically does the same thing Microsoft's system does. They actually use Amazon storage rather than HDFS. And then HD Insight is the one we're looking at. And many vendors' products that run on Hadoop or integrate with Hadoop. Everybody okay so far? Is it time to do some code or something, or run some jobs? All right, here it goes. So let's see if our Hadoop cluster is finished here. Okay, there it is, it's up and running, cool. So we've got it over here. Now one of the things we can do right away is we can set this up so that we can actually RDP into it. So let's do that because we want to look around the cluster, why not, right? So over here, under configuration, you can turn Hadoop services on or off. The way we're going to deal with Hadoop is actually through Hadoop services, and we're going to submit jobs to Hadoop from afar, from my machine using PowerShell. And this uses actually an API called Templeton, which is a REST-based API as well. So basically, we have some classes that encapsulate the Templeton APIs, and if you don't want people doing that, you turn it off. And we want it, so we'll turn it on. The other one is we'd like to enable remote access to what's called head node. The node that's, the head of everything is called the head node. Now it turns out this is weird to me. You have to put a different name in here. And again, I probably have to have, let's see, password. and then that, and then 1, 2, 3, of course. Because you've already seen me mess around with my password, you don't want to do that again, right? And it expires, and you can tell it when this access expires on. So today is Friday, let's have it expire on Saturday. Okay, great. So we'll set that off. And while that's working on things, we can go back to our storage account, and we can actually see what's happening over there. So our storage account we should have over here. Let's go look at the storage account. Let's get rid of this junk. There we go. Look at our storage account. And we had to unfortunately make one specifically for Hadoop. Where's the storage account you had to specifically make, Bob? So we'll go over here and is this tools? No, not tools. I just want to refresh. Okay, so F11 out of this. We'll go back and refresh that. And there better be a fourth storage account. Come on. There we go. And you wondered why I didn't even put big data in, right? I've been having trouble refreshing the storage account list. There it is. Remember we made one called new BEAUCH, and that's where Hadoop is actually living. And so to see that, you can actually either use this GUI, or I actually like the GUI at the bottom better. So what we need to be able to use that GUI is we need the access key for that storage account. So basically, if I'm the administrator and I do this, then it'll let me copy and paste the access key in. So for goodness, so for this guy, I can add a storage account, new BEAUCH, and there's my storage account key. Nobody memorized that storage account key, and we'll add a storage account. Good. It says the first time it might take a while. Fine. There we go. So there's our Hadoop 3 directory. And by the way, these aren't directories at all. Windows Azure Blob Storage, which is what this is, basically has one level of containers right here. And the only container that we have is the Hadoop 3 container. After that, we have what looks like directories over here. But the reason why they look like directories is because we actually named our files with forward slashes in the middle. That's all, right? They are not directories at all. In fact, I found that out the hard way when I needed to put some data out there. And I thought, well, I have to have exactly all the levels of subdirectory. And not only did it work, they got upset at me doing that. Okay, so we're going to run the word count, really, of course. This thing comes with, so basically what is out here is my Hadoop that we're going to use. Come on, where's my, there we go, move this over. So there's some examples over here. There's the Hive Data Warehouse over here, so you can see Hive Data Warehouse. And the Mapreduce history, basically there's a lot of, goodness, logs in here. And user, and, oops, come on. There. With the big hideous fonts, it's sometimes hard to do that. It's over here. Notice I have a user called HTTP. That's the internal user. HTTP stands for Hadoop Data Platform. I'm sorry, Hortonworks Data Platform. And then it has some jar files underneath it that we can use to run stuff. In addition, there should be one for my users somewhere in here. And so basically, and there's pig. This is the default file system of Hadoop. In fact, it's so much the default file system for Hadoop that if you RDP in and use the built-in Hadoop command line utility, you'll see this file system rather than HDFS. The only way that you can get to HDFS is with a URL that actually says, I would like to go to HDFS with this URL. So what does he mean by that? So we've got access over here by now. Let's go back to our Hadoop cluster. No, just like that. These scroll bars are just crazy. Sorry. There we go. And there's the Hadoop cluster. And so since it had enough time to make me RDP access, I can go over here and say connect. And it'll open up an RDP, and we'll just open it. And now we're actually connecting to our cluster itself. We're connecting to the head node. Oops. Come on, type. $123. Okay, good. Remember my credentials. There. So now we're connecting up to the node. Okay. One more time. WORP $123. Okay, one more time. basically this will get us into the virtual machine where Hadoop is running. Remember, I asked for a cluster of 2, so there's 2 of these. This one is called the head node because this is where everything's running. It's taken a while to set up. There we go. Oh, these ones are running on 2012 release too. That's good. Oh, we've got hideously small fonts up here, and I don't have a, what do you call it? I don't have a magnifying glass up here. So the only thing you can use to tell that this is version 2 is there's, let's see if I can do this anyway. No, it won't let me do that. There's a little icon over here that tells what the Hadoop yarn status is. And we'll talk about what yarn is in a little while. But basically, Mapreduce by itself in version 1 was replaced by yarn in version 2. What's the difference? Mapreduce can only run Mapreduce jobs. Yarn can run any kind of job you want. So version 2 sort of opens things up so that they're not just stuck to Mapreduce. But this is a fairly useless exercise here because maybe I can see in here, but you can't. Right, and you can see that there's a file system there that actually has directories for configurations and applications and so forth. Okay, so you can actually RDP into the head node and submit jobs from there. Or more fun is to actually submit jobs from the PowerShell script. Now, when I said that that Azure Storage is actually the default file system, there is a command shell command called Hadoop right here. And basically it's set up in the right directory so I can run the command Hadoop. And this will actually show me a bunch of choices that I have. You can use this to submit jobs. What I want to have it do is look at the file system. And the way you look at the file system is Hadoop -fs, and then give it a file system command, like ls. And so if I put ls in there, oh, it's not having it wrong. ls, sorry, slash, there. No, ls dot. Not happening at all. Okay, anyway, this is the way you look at the file system, but if you do this from here, you get the Azure file system. Everybody okay? It took me a while to get through this as well. So let's submit a job. Apparently I can't do it from the command line. I didn't want to do it anyway from the command line. I didn't want to do it anyhow. Okay. So the other way that you can submit a job, which is preferred, is to actually use the PowerShell commandlets to submit the job from afar. So the way that you use the PowerShell commandlets to submit a job from afar is you actually go into, you download Windows Azure PowerShell. There's actually a PowerShell for Azure. Yeah, there's a library. And you install it. And when I did that, it actually gave me its own command shell. Notice I've got now 3 or 4 PowerShells down there at the bottom. And hopefully this has the right non-hideously small size fonts, there we go, to be able to run things on it. Okay, great. So what I want to do is I want to run a PowerShell job that actually runs this word count job. And the way that I would do this is go to the directory right here. So let's under scripts, under DevWeek, under Hadoop. This is really risky, you know, doing non-GUI demos in front of people. Right, I was told before that people love GUI demos. That's the way they do. If you run a non-GUI demo, which is what I'm going to do here, you take your chances. Okay, so I'm right here, and the word count that I'm going to run is right here. Submit word count.ps1. So basically, in PowerShell, you set a bunch of variables in there that says what the subscription name is. What subscription name? The Azure subscription name. What was my subscription name? Windows Azure something, right? And I have it already in a file. And then what's the name of the HD Insight cluster? Oh, that's BBAUCH, sure. So rather than to set these for every single script, I have these in a file. And there's the file right there of configuration variables. It's the Windows Azure Cloud Essentials that live here. Oh, but I have to change my storage account now. So BBAUCHEU is actually new. BBAUCH, right? Because for some reason it didn't know about my other one. There we go. Okay, great. And my container name is Hadoop 3. You saw that it was up there. Okay, so now I've got these variables all set. And I'm actually going to run them and keep them in the environment by using this thing. Basically, if I say dot space dot, it'll keep all the variables that I've set in the environment. So this is Hadoop vars. Oops, if I spell Hadoop right, it would be good. Come on. Here, .ps1. Okay, so now I have those variables in the environment. Let's go back to the script that I was going to run here. So the first thing that you have to do is select an Azure subscription. Again, this is only needed if you have more than one. I happen to have more than one subscription. Then define a word count job definition. In other words, there's a job definition that you get by actually using the commandlet new Azure HD Insight Mapreduce job definition. And what are you going to tell the job definition? What jar file is going to be out there? And what's this thing? So everybody can go by URLs. And if you want to submit things through Templeton, that's the remote API, you actually have to use URLs for Windows Azure Storage as well. I take it back, I don't think you do. It's not required. But you certainly would have to do it for HDFS. This basically says the jar file is located in my Windows Azure Storage under examples, jars, Hadoop Mapreduce examples.jar. Now let's make sure that that's the case, because they do lovely things like changing the name of the example jar file. Really? Okay, Hadoop Mapreduce examples.jar under example jars. And that's right, okay. And then what you tell it is, in this jar file, which class name do you want to run, and what arguments do you want to put in? So basically, this is the text file he would use to count the words. Most of this stuff is text file based. Almost all of it is. And basically, you'll tell it what the output is going to be. So we have one of those, or we can count another one if we want to. And then submit the job. This is start Azure HD Insight job on the cluster that I want with the job definition that I want. And then sort of wait for the job to finish. So this is why you don't run big Mapreduce jobs in front of people. Watch this. So we'll actually run that one. So this is submit. Oops, come on. Submit. And then what was this again? Goodness. Submit dash word count.ps1. Okay. Submit dash word count.ps1. There. Okay. And watch what will happen. So, oh, lovely. What did I mess up? Oh, it's PowerShell. I need the leading slash. Right. Did I mess something up badly? All right, am I in the right directory? I'm in the Hadoop directory. And what's the name of the
dot slash?
Sorry?
You want to do dot slash?
Oh, right. Dot slash that, sure. So we'll do that. Yeah, part of it right. I can't think and type at the same time. Thank you. Okay, that's better. So this is the nice thing, and this was the problem with MapReduce. You basically submit these things and you go home for the evening, right? And if it does anything more than count words, you're actually going to be waiting for it to do something other than count words for quite a while, right? So far, it hasn't even submitted. There we go. It's now initializing the job. See that thing, that green thing? I'm easily amused, right? But that's the way you can see it actually worked. Thank you for the dot slash. And basically, it's got a job ID right there. It is running. It hasn't yet got to the map part of MapReduce. Again, how come this is? Well, I have 2 empty machines, right? I don't have a big cluster of 40,000. But even so, I would have to take those and split them. And I don't have a really big file either. There we go. It says how much percentage is done. Map 0%, reduce 0%. And by the way, this is exactly the same way that it works when you run a database query as well. Really, right? And so there I've got 100% of my map done, and now it's working on reduce. So I could run the Mahout example, but the Mahout example goes through 8 iterations of MapReduce. You probably don't want to see that. Okay. There we have 100% reduced, and it will eventually come back with the answer. Okay. It actually doesn't come out with the answer, it comes up with some statistics about the job. And so what you have to do, there we go. So there's all the statistics about the job. You have to go and fetch the answer. Where was the answer? Oh, it was out on the file system. Okay. So there's a script to go and fetch the answer, of course, because I'm lazy, which is get word count output. So we'll run that. Get word count output. There. Okay, we'll run that. That's not as slow because that's just going up and getting the thing out of storage and displaying it. So now it's got the Azure storage key, hopefully, if I set this up right. And then, come on, ooh, didn't like the Azure storage key at all. All right, so let's do it the other way. Where was my word count output up here? So we'll, goodness, Where's refresh? Am I not seeing that right? Oh, there it is over there. Good. And so there should be a word count output under examples, and you should see that it's right. Notice I now have a bunch of logs that are taken up. And these word count outputs are called, because I only executed this on one machine, word count and then part R0000. So if I executed on 500 machines, then it would have 500 of these files. Everybody okay with this? And I can actually download the file from here. So we click that and we'll do download the file and we can see it on my machine. Apparently I screwed up something with getting the word count output. And there we go. So it should be in my temp directory over here. Let's just bring this up. And it wasn't that painful. Well, yeah, but it would work the same way if you're doing this as if you're indexing the web. You just have to wait longer, right? So here we go over here. And there should be there it is, example word count output. And if I actually look at this, open with, and I really want to, since this is a Unix-based system, or a Unix-based system originally, let's see if I can get away with it. Open with Notepad? No, I have to open it, of course, with WordPad. Sure. So WordPad will actually do the right carriage returning line feed for people that are used to Unix, or that Unix does. Okay, where's WordPad? Oh, it's right down here. Okay. Yes. There it is right there. Okay. So there's my list of words and how many times they occur. And notice because we've gone through the reduce step, there's some of them that occur more than once. Everybody okay? Not really flashy, right? But we'll get to the non-flashy part later. So what have we got? Half an hour to go? Okay. Let's run another couple of jobs here. So the next one I want to run is a pig job. And this is a sample pig job. This is the one that you'd run if you were from Yahoo. And basically what the pig job does when you edit it, oops, not with the PowerShell thing, is it will actually, well that's fine, we can do it that way, but let's bring it up here. Okay. Not edited, but open with Notepad. There. Is pig actually uses variables that are in uppercase and steps through variables. So what this is doing is saying, I'd like to load this particular sample log into a variable called logs. Then I would like to break the logs up. For each log, generate a regex of extract. And then once I've gotten that, I want to filter those levels by actually the error message that I get. Then group by, here's my group by, right, group levels. And then for each of the group levels, generate group as log level and count. There's a count over there. So what am I doing? Counting group by. Really? Yes, with Mapreduce. And then dump the result. Everybody okay with that? We can run that and I'll show you the highs and low we're going to just snap things up a little bit. Okay, so here we have it here. No, that's not it. Here we have it here. And so let's go ahead and submit the pig job. Here we go. Submit pig sample. Okay, there we go. Let's hope for the best here. There. Okay, and it'll do the same thing. While this is going to do this, I can show you what the Hive sample looks like. Hive looks a little more like SQL, but by the way, it's actually going to do the same kind of MapReduce stuff that this does and that MapReduce did. And by the way, what are pig and Hive in the first place? They're just meta macro languages over MapReduce. People got tired of writing MapReduce programs for everything. And so rather than write a MapReduce program every time, they made up a high-level language. Sounds familiar. And one person wanted their high-level language to look like a, job language, and the other one wanted it to look like SQL. So here's the Hive job right here. So there's my Hive sample over here. And this one in Notepad will actually do show tables, and then there's a sample table. So select star from Hive sample table, where country equals UK. Now that looks a little bit better. That looks more like what we're used to. And again, the way that you submit these jobs is not particularly, wonderful. That's why I'm not going over each one. You basically set up the same type of job you did before, and then submit the job. Actually, Hive has a nice shortcut. You say invoke Hive. Everybody okay with that? Okay. One more. So Uzi is actually the workflow language, not Windows workflow, but it's the Hadoop workflow language. And so basically what Uzi does, where's Uzi over here, is they actually have a workflow language of their own that's based on XML. And so what we're going to do here in this Uzi job is we're going to have a workflow called workflow.xml. And this XML workflow is going to, he said, there we go, run a Hive script, and then with this configuration, and then that's actually going to put out output data, and then we're going to run a scoop export. And notice that, oh, I'm sorry, this is the name of this step. So what it's going to do is take data from the database and put it out to the file system. And if we fail, then we go on, we skip the rest of it. And if we don't fail, then what we're going to do with this is actually run a job that actually connects to SQL Server and puts that information into SQL Server. So it's basically a bulk insert. Everybody okay with this? Okay. I'll skip through this a little bit and we'll do the rest of the slides. Well, everybody else gets to leave at 5 o'clock. Well, you can leave at 5 o'clock if you want. I got lots more slides. But you knew that coming in, right? So, did this pig thing finish yet? There, the pig thing, okay, it's now finished. And I believe that this particular one actually puts out output. Again, oh, there we go. So, of my log, there is 816 trace rows, 434 debug rows, and so forth. Everybody okay with that? Any questions? No, I thought you were going to ask a question. You were just stretching. Did you want me to run the Hive one? There's not much to it. It looks like a SQL query. Okay. So let's go back to the slides, and I'll show you what's cool and interesting about version 2. Because to me, version 2 looks like, oh, just like version 1, I was happy that all the jobs ran, and all I did was really upgrade Hadoop, and that's true for most of the stuff. So Hadoop version 1 was available in 2011, meaning what? This stuff wasn't around for very long. Now Hadoop was actually invented at Yahoo in 2007, but if it was released in 2011, you're one of the first people that use this. Right? This is why they call me the shiny new feature person, right? Because when I see something that's new, it's like, oh, this would be cool. Nobody else knows how to do this. Version 1 is just Mapreduce and HDFS. And the Microsoft Hortonworks implementation, the 2.1 implementation, is based on version 1.3. And basically, Hadoop's architecture in version 1 consists of a series of nodes and trackers. So basically, HDFS has what's called a name node, and the name node is going to keep track of where all the files are in the grid-based file system. So that's what the name node is. And right now, it's also a single point of failure. If the name node fails, then you actually have to manually bring up the secondary name node. So there are 2 of these out here, but they don't fail over automatically. In addition to that, there is only one name node, and there is only one secondary name node. For each machine, you can have a data node. And basically, data node is where they put the data. If this is a master and slave system, and I have 40,000 machines, I'd have one name node, one secondary name node, and 39,998 data nodes. Everybody okay with that? That's for HDFS. For Mapreduce, they have one master over here called the job tracker, and there's one per cluster, and you submit your jobs through the job tracker. The job tracker runs your job by actually distributing it out to these things on every machine called a task tracker. So when you want to see where your HDFS data is, you can submit a request to the name node, and it will go out to the data nodes and see where they are. If you want to run jobs, you submit it to the job tracker, and it will go out to the task tracker and distribute your jobs and run them. Everybody okay with that? And usually the way these are configured, unless it's a huge installation, is the name node and the job tracker are actually on one system. And this one particular machine is known as the head node. And that's actually the one that we went into with RDP. Hadoop 2 basically was out this year, or last year. So it hasn't been out for very long at all. And I guess people got tired of running only Mapreduce. And especially with the way Hive did queries, they wanted to be able to run something faster, something interactive. And Hive 2 is about, Hadoop version 2 is about separating the Mapreduce from the HDFS. In other words, HDFS stays the same in release 2, except that it is failover. It knows how to do failover now. And we've separated the internals of, we separated the internals of Mapreduce from the rest of the system. So in other words, there was this big system, Mapreduce, and it scheduled jobs, it ran jobs, and they ran under Mapreduce. In Hadoop version 2, they separated out the resource negotiator, which is called Yarn, from the actual things that run jobs. So what do I do again? In version 1, we had HDFS. In version 2, we had HDFS. HDFS didn't change. In version 1, we had an integrated MapReduce that would do everything. That's why it could only do MapReduce. In version 2, they take MapReduce and cut it in half. The thing that actually gives out resources to jobs is called Yarn. And they can give out resources to MapReduce jobs, or they can give out resources to other jobs. For example, there's an interactive now version of Hive in the latest version of Hadoop that you can submit jobs interactively and they don't have to go through MapReduce. And that one basically runs under Yarn. The regular MapReduce runs under Yarn. And there are other types of things that run under Yarn, like what? An in-memory database, a streaming system for large numbers of readings from machines. And these all run just fine under Yarn and compete with MapReduce for resources. So what is this? This is Hadoop takes over the world, right? It could only do one little part of the world before this. Now it can do everything. There's an interactive Hbase, so you can do queries against Hbase. And there's a bunch of different things coming up to make things faster. In fact, they also wrote their own interactive database, Cloudera did, that actually did multi-node distributed queries called Impala. Everything is named after right? So again, it separates the parts of MapReduce. Now, it separates the job tracker really into two. One is called the resource manager, and you submit your jobs to the resource manager. The resource manager also schedules resources, but that's all it does. For every job that you submit, or maybe you can use these, you have what's called an application master. And the application master does half of the work that the job tracker used to do, and the other part is done by the resource manager. Everybody okay? And the big deal is that the resource manager can manage resources for MapReduce or anything else you want. Everybody all right with that? So I, at that point, asked, so how does MapReduce run in this world? And how MapReduce runs in this world is every time you submit a MapReduce job, you submit it to the resource manager, it spins up an application master. The application master goes back and asks the resource manager for resources, and then it distributes out the work and runs it. So your distribute out the work part is actually done by the application master, and the schedule and get resources and keep track of global resources is done by the resource manager. Everybody okay with that? And this is supposed to be cool because you can run things other than MapReduce. But you saw all the jobs that I did then were MapReduce. Yes, sir?
So if the resource manager goes down, then the whole thing goes down.
Sorry, say that again?
So if that master node, the one the resource manager goes down, the whole thing goes down.
Oh, the global resource manager?
Yeah,
Yeah, the global resource manager, I believe in this one actually has failover, but I have to check that. I know HDFS head node now has failover, automatic failover. But yeah, this would be the single point of failure right here. All we've done is move the single point of failure, right? But I would have to actually go and look because I'm not sure of, when that goes down, is that actually brought up immediately? Secondary one. So far, so good. And then besides the application master and the resource manager, on every node, there's a local resource manager and a local node manager. Okay. And that's the version of Hadoop I'm running there. Now, how did MapReduce look? No different. But could I do things other than MapReduce? Sure. So Hadoop on Windows. So what happened was, Microsoft has a product. Let's spin forward a little bit. Microsoft has a product, called the Enterprise Data Warehouse product. In fact, it's sort of like a piece of hardware you can buy, right? It's an appliance. And when they had this appliance, the Parallel Data Warehouse, they wanted it to take in not only data from SQL Server, but big data. And so when they wanted it to take in big data, they expanded it. So it can get data from SQL Server, and it can also get data from Hadoop. That's really what they wanted with Hadoop. Besides that, and Bing running its own MapReduce jobs. Right, in fact, Bing runs MapReduce jobs using something called the Dryad project. And the Dryad project actually doesn't use Mapreduce. It uses 4 different types of steps. And so you can do things like map, reduce, map. You don't have to have steps of 2 for each one. So that's something they worked on. So why they wanted it was to integrate with this thing, with the parallel data warehouse. And their integration of it has already shipped, and it's called Hbase. And Hbase can do queries between SQL Server data and big data. And that was the whole point of this thing, right? They're a big appliance. Now, unfortunately, nobody can use the big appliance unless you buy one. It'd be nice to have one on Azure, wouldn't you think? So that people can actually go up and play with it and look at it like that. And so again, Hbase integrates Hadoop. You basically just say create table with a Hive table name, and it knows how to use that. Everybody okay with that? So that's what Microsoft's interest is in it. If you want the nefarious view of the world, right? If you want the non-nefarious view of the world, this is this lovely open source community, and they're going to be part of it. Okay, but they actually have put in a lot of work. It turns out they did put in the work to make it run on Windows Azure Storage, just like Amazon put in the work to make it run on Amazon storage. And what they've done so far with this Hbase, and this just came out yesterday, so I don't have it to show, is they took their 2 big data warehouse people from SQL Server. You might have heard of these people. One's a guy named Eric Hansen, and the other one's a guy named Remus Rossano. Remus Rossano is known for the service broker, and Eric Hansen is known for the column store feature, and also the batch mode processing. And what they did is they took them and assigned them to Hadoop, so that all the things that the column store can do in SQL Server, Hadoop can do as well. And this is going to be known as Hive version 13. The one we have right here is Hive version 12. So they've taken and assigned their own people to it. Maybe you're not an Eric Hansen fan, right? Or you don't know who Eric Hansen is. Everybody okay with that? That's the nefarious view of the world, right? That's what they really wanted. So they were going to take over this company. This is my own story. They were going to take over this company called Yahoo, and they were going to take it over so that they could use that to, enrich their Bing data. And when they went to take over Yahoo, they realized that they couldn't just take over Yahoo and have this stuff integrated. They would have to take over Yahoo and have the Yahoo people run this, because they have their own system that uses Pig, and those guys have their own system that uses Dryad. So instead of taking them over, they went to the Hortonworks folks who used to work at Yahoo, and they said, help us port this to Windows. Right, this was never on Windows before, it was always on Linux, so we want this ported to Windows. And so Microsoft and Hortonworks worked to port Hadoop to Windows. And there's 3 flavors of it that run on Windows. Even though I've done Linux in a previous life, it's always nice for me to bring up the file manager and figure out how to find the files that way, So the 3 flavors are Hadoop on Azure, which is called HDM site, the Hadoop emulator, which is a single machine. Somebody might have shown you the emulator earlier in the week. And then Hortonworks Hadoop on Windows, which is basically the same as their Linux distribution that runs on Windows. Now, what's interesting about Hortonworks Hadoop on Windows is basically you can run an entire cluster of 40,000 nodes without Azure whatsoever. In fact, what they recommend is if you want to run a local cluster of Hadoop, you get this thing, you get Hortonworks thing. If you want to run things and only pay for it while things are running, then you would get this thing, the Hadoop on Azure. Everybody okay? So they originally were going to build their own multi-machine system, and they decided, Hortonworks has a perfectly good one. Why bother? So there's HD Insight, and you saw the cluster can be spun up at any time. The software portion is provisioned on the node's file systems, and the data is provisioned on Azure Storage. HDFS is provisioned and available, but we use Azure Storage by default. And this allows us to save the data after we're done with it. So if we brought the system down, deleted the cluster, if we brought it up again and deleted and just put the cluster back in, it would have all our Hive metadata, all our Oozie metadata, and also all of our data that we had out on Windows storage. Okay, that's the point of it. It's, again, the same way that Amazon Elastic Cloud works. So I'm not going to do this. That's sort of a ransom note picture. You can look at that in your spare time. And basically, they have 3 versions. I told you about those. They don't match the Hadoop version numbers. And basically, what they include is a subset. of the products that come with it. So for example, there is no Flume in this world. And Microsoft doesn't provide Flume because they don't use this to manage their own logs. They actually have a System Center management tool for this. You can manage it with System Center. They also don't have Zookeeper. And when I asked why they didn't have Zookeeper, I was told that nobody's ever asked us for Zookeeper, so we didn't import that part. And notice there's no Mahout in here as well. So if you want to do predictive analytics, you would have to actually take Mahout jar file and just put it out on Windows Azure Storage and run it from there. And it's just that easy. There's a Mahout example that that's exactly what they're doing. Go to this place, download Mahout 0.8.jar, put it here, run the job. And pretty much anything else you want to run, you can do that way too, that they don't support. And then since all this stuff is based on Java, there's a Odbc Driver for SQL Server. So additional packages, so we don't have this. The one that everybody seems to be the most upset about is Hbase. For some reason, people think that Hbase is sort of like a database, although there's no query language to Hbase. If you want to get the data out of Hbase, you write Java programs. So it's not like it's not even integrated completely into Hive right now, although they're working on it. These can be installed and built, but they're not supported by Microsoft. So other related products, the implementation, the integration with Windows Azure Storage. I was kind of shocked. I have to ask about this again. There was a guy that asked the people from Microsoft, so if this is open source, and you contributed to the open source, thank you for coming. That's okay. What I actually want to do is I want to get the source for this, right, the integration to Windows Azure Storage, and integrate it into a Linux version. Can I do that? And he was told, no, it doesn't run on Linux. Well, that's not open source then. But then I was told after that that it sort of does, and the person there didn't really know what they were talking about. Again, HCatalog, Hive, and Uzi can be provisioned on Windows Azure SQL Database, and that's what we did. Right? In fact, I haven't run any Hive jobs, have I? If we go out there and run a Hive job, we'll see that, in fact, we should see the metadata anyway. So if I go out here from that, if I do systables now, ooh, right, there we go. So you should see there is the Hive and the Uzi metadata tables. And what's this, SERD? So this is a serializer and deserializer. Hive can consume anything for which you write a serializer and a deserializer. And basically the first thing Eric Hansen did was write one for a column store. Everybody okay with this so far? All right, I'm almost done, especially at the end of the conference. Okay, so what they did, Hortonworks and Microsoft made up this project called the Stinger Project, the Hive Stinger Project. And basically it was a way to run interactive queries in Hive using Hadoop version 2. So the queries in Hbase could be interactive, right? So they wouldn't have to use Mapreduce. And Stinger actually is a 3-part system, and actually now all 3 parts are done. I did the Hbase one, and here's Stinger. So in the 1.6 version we have of Hadoop, there's phase 1 of Stinger. And basically this is a file called the ORC file. And the ORC file is column-based storage. So this is the equivalent of column store done over again for Hadoop. Also, there's the SQL Server windowing functions. So all the windowing functions like lag and lead and those type of functions are integrated into Hadoop because, of course, SQL Server had implementations of them. And finally, there's optimizations over the DAG is what everybody generates, which is directed acyclical graph. Basically, it's a series of MapReduce steps that you use to do a query. In fact, I always like to think query plan, right? Directed acyclical graph is a query plan. In phase 2, which they have right now, there's additional data types like, believe it or not, varchar. All the Hadoop stuff, because it's reading off of files, doesn't really have always a set of rich data types. And date was another one they put in there. The Hive query server has pre-warmed up containers, so it'll run faster. You don't have to go out and ask the resource manager for a container and then allocate the container and then use the container. When you bring the system up, it has a bunch of pre-warmed up containers. And then there's another project called Apache Tez. Tez, I believe, is the Hindi word that means faster, right? And so basically, this is a fast version of Apache Tez. It turns out you do not need Tez to run this version of Hive, but if you run it, it's going to run even faster. And then phase 2 is what they just shipped. So what they call batch mode in column storing SQL Server, the Hadoop people call vectorized query engine. But basically it's the same thing as batch mode. What's batch mode again for people that aren't SQL Server people? Normally when a database does queries, it actually does the queries one row at a time. So they're pretty slow if there's a lot of stuff to be done because they're doing them one row at a time. Batch mode will actually do it 1,000 rows at a time. So it's much, much faster. And this is the thing that Eric and Remus just got through with. There's also a query planner. So now you can actually see the query plans for Hive like you would for, say, SQL Server. And also there's buffer caching in phase 3. So the problem with Mapreduce is you have to do Mapreduce and then put it out to a file. And then the next step reads it from a file and does something and puts it out to a file again. And you do that for as many times as you have steps. So what these guys have is a buffer cache. I wonder where they got the buffer cache. Right, the SQL Server buffer cache, perhaps? And they use the buffer cache to buffer intermediate results so that they don't always have to read them from files. So is this not SQL Server as a Hadoop engine? And it's like pretty close. So this was released yesterday and it includes the latest version of Yarn. It also includes a version of Tez. So I said we were going to have Tez, and it has the version of Tez. Also, Hive 0.13 is actually the one that does vectorized query execution. Storm is the thing that does streaming. So if you have things that come out through, mechanical pieces of equipment, like if you have shop floor items and they're always producing readings, you could use Storm to actually stream them in. If you're a SQL Server person, this is similar to the product they have called Stream Insight, not made by the same people. Solar, I've probably heard of Solar, is a search engine that actually uses this version that uses Mapreduce. And Falcon and Nox. One of the strange things about this before was that they didn't really have much security. And so if you're going to have a data warehouse with things that managers will want, they like data security. So Nox is actually going to be integrated into Active Directory. Hasn't been yet. Okay. Then there's the Odbc Driver. So there's a Hive Odbc Driver, and that's what I want to show you last. Right? Because this actually looks like Odbc, except it takes forever. So if I go up here and I want to do the Hive query, I can submit the job and do it like this. This is our Hive query, select star from Hive sample table where country equals United Kingdom. So let's cut that Hive query out because we're actually going to be able to execute it. What we would do is we'd go into the control panel. Come on, over here. And in control panel, we actually have under administrative tools, the Odbc data sources. And since my machine is a 64-bit machine, I have a 64-bit data source. You can also get 32-bit. So over here it gives a list of data sources, and one of my data sources is the data source for Hive, where it these drivers. So I should have the Hive data source in here someplace. I don't see it. That's not good. Okay, these are the Odbc drivers that are installed in your system, but I don't see Hive, which is intriguing. How about DSNs? There's the user DSN. Okay, so there's the Hive HT Insight Odbc driver. I'm not exactly sure why. Oh, I know why. Because I'm looking at the 64-bit administrator. I stupidly, when I was doing this, installed 32-bit Excel. And if you install 32-bit Excel instead of 64-bit Excel, you have to use all the 32-bit drivers. So there, if I bring up the 32-bit administrator, the Hive driver should be right there. There it is, right here, Hive Odbc driver. So in my new VM, I actually have 64-bit Excel installed. Okay, great. So what I'd like to do is I'd like to make a new DSN. And in this case, the Hive HT Insight DSN is already there. So let's reconfigure it to point at my new server. In fact, it will point at my new server already, right? Because I named it the same as my old server. So basically this says, here's an Odbc DSN. It's actually going to point at bpach.azurehtinsight.net, and that's fine. When they introduced HT Insight, they went and started to use port 433 everywhere, because that's the HTTPS port. And database, I want the default. Hive actually has the concept of multiple databases. And you can create a database in Hive and put tables in it, and you can have more than one. And then it says, what is the Hive server type you want? Because this one is not only going to go to Microsoft's one, but it's also going to go to other implementations. And so you can have Hive Server 1, Hive Server 2, we want 2. And then it says, what type of Hadoop are you going to look at? Okay, and this is which you can do regular with Kerberos, so Linux with Kerberos, Linux with no auth, Linux with user ID and password, and you can see them all here. Notice that the emulator, if you ever run the emulator, is a different service itself. And then what it's going to want is the user ID and the password here. I'll just leave the path the way it is, it's fine. And hopefully I can get this to work. So there, WORD $123. Okay, and there's some advanced options here, but let's see if we can get as far as test. So here's the test coming back. And what's it actually do when you do a test? Well, it's actually going to submit a job to see if see if the server is there. But it's not actually going to run anything, otherwise it's doing Mapreduce. And there we go. Test successfully completed. Everybody okay so far? So let's take Excel and go in and run our query. So now that we've got this set up, Hive HD Insight, we can go into Excel. And there's a couple different ways we can use with Excel in order to do this. One is we can use something called Power Query. And Power Query is a way in Excel that you can do queries against data sources. And I think it's funny the way they implemented this in Power Query. There is no Odbc data source here. There's MySQL, there's DB2, you can read them as well as I can. But from other data sources, they have regular Hadoop on HDFS, and they have Windows Azure on HD Insight. So let's do the one for Windows Azure on HD Insight. In other words, rather than go in through Hive, which we're not doing at this point, what this is going to give us, I would think, is a listing of that Hadoop 3 directory. However, what it actually does is give you a listing of everything that's on the storage account, which I think is fairly strange. In other words, it will do things that are Hadoop, and it will do things that are not Hadoop. It doesn't care, right? But it is the Hadoop data source from HD Insight. So we'll check that one. Here we go. And we'll go get our R00 or whatever file. So the account name that I'm on here is Rob B. Okay. And is that the Azure Blob Storage? Oh no, that's the Azure Blob Storage account. So that's new, BPEAUCH. That's right. Go. And it's actually going to use this, and of course the account key. So we have to go over here and fiddle around with the account key. Sorry, here we are. By the way, do get your patience ready when you start to work with this stuff. Never mind the fact that Mapreduce is slow. You're constantly copying and pasting keys. Okay, so there's the key right there. You only have to do this once, by the way. And then when you do this, it's actually going to connect up to the storage account. There's my Hadoop stuff right there. And when it's loading a preview of what's there. And notice what it does, it just loads a preview of everything that's out on the file system. Which is not really Hadoop to me, but they seem to like it. Everybody okay with this? You can click over here. And when you click over here, it actually brings up a set of information about what's out there. Where's my R0001? My word count one? That should be right over here. So you click on binary, and that gets imported into Power Query. There. So there's my Power Query right there. And then it says, and you can go in and rename the columns yourself. Well, that's not what I really want, right? To go in and rename the columns myself. So the other way you can deal with this is you can go in as a data source. So this stuff always bothers me. No, just discard. So what I'm going to do here is instead of Power Query, I'm going to do data. And under data, I actually have an Odbc data source right here, the data connection wizard. It says the data connection wizard is for old EDB, but technically there's an old EDB data source for Odbc, and so this is the one I want to use. And by the way, if you're doing this, you have to be really patient. Click once and let it work. If you do what I do and click twice because you think you've missed it, it'll click twice and go off to some other screen. Right? Okay. I want an Odbc DSN, and the DSN I want is for Hive HD Insight. Okay, great. And there's the DSN again. Somehow it makes me type all that stuff in again. So this is PASSWORD $123. Okay, and just test it to make sure. It took forever to test it before. Let's just hope for the best. Go. Okay, now you sort of have to, it doesn't look like it's doing anything. but it actually is. Eventually, oh, what is it? It's waiting for next. Okay, next. This is the one where I always hit next twice. Oh no, see, look at that. I didn't hit anything at all, you have to wait for it. Lovely. And what it will do is it will actually go out to the Hive system and find all the Hive tables. There we go. And this is a table of Hive metadata called Hive system. I want the Hive sample table right there. So there's Hive sample table, go. And I shouldn't have done this because it thinks I want to use an ODC file. So finish, and you already have one, fine, replace it. And now go ahead and put it in this chart in Excel. I'm the world's worst Excel programmer you ever want to see. Right? And this is that, 1, 2, 3. And once we do that, amazingly, after all this stuff, we get a grid of data. Wasn't that easy? You have to be patient, right? And notice what's it doing? It's running a Mapreduce job. And how long are we going to have to wait? For a while. So let's go back and just look at the summary slide while we're doing this. It's about time to wrap up. And hopefully you learned some things from this about Hadoop, even if you knew a bunch. So there's the additional integration right there. Oh, by the way, there's an SSIS connector for Hadoop too. So if you use SQL Server Integration Services, you can use that. So management is done from the Windows Azure portal or through the PowerShell commands. There's also system selling and submitting jobs we saw, and PowerShell commandlets we saw. And there's also a .NET SDK. There's a link to Hive. I really want to know how long I have to wait for it to get to the first line of the link to Hive job. And so now, what we have is a Hadoop that runs on Windows. It's the latest version of Hadoop, and it actually stores all of its stuff in Windows Azure Storage. Do I have any questions? Yeah, no questions at all. Okay, well, I now declare the conference over. Thank you to see, I can do it from up here. Thank you for coming, and I hope that was useful.